Hello together. Today we will talk about code organization in Rust. I will talk about modules and features and how to use them. Therefore, I will show you some code examples and then we will dive into more widely used projects in Rust. I created a new project with cargo new. To go a step further, as we are talking about code organization, I create a new file, librs. In there we will define two new modules. As you can see, the Rust analyzer is already annoyed, but he's simply saying he's missing these both modules. He's looking for either of two files. You can create a folder and put a modrs file in there and reference further, or you can just create a file of the named module. We will do the latter one first, so I will create a file. And in there we can now define some functions. As you can see, the functions are private by default, therefore we always need to add a pub keyword in front of it. So I will simply print out some message like I am mod1. This is our util function. And now we take the second approach. So I create a folder called services as we called our module, but now it's still complaining as we need to create the module.rs. The Rust analyzer is happy. And in there I create another function with the text I am mod2. And this is basically how you can implement a modular hierarchy, but for the sake of showing you how to organize it now, I will use that directory to organize my files I want to have in the services folder. For example, some service. And now I create just a file called some service. And I rename this. And here I can actually now put in my function. If we now want to invoke it, I need to use the name of our project, which is called Fun with Modules. If we now execute the code, we will see I'm a service and I'm mod1. Our expected messages. Now let's get a step further and talk about features. As you may have seen in the cargo toml, if you are using imports and other dependencies, for example, you will come around where you say that you import some features or you don't import them. These features can be defined in your library in here. Let's call one f1 for feature 1. This is our feature and it has no dependencies. If someone will use our library right now, the person could just import fun with modules and then add this feature. But what can we do with that right now? It's quite simple. We are able to use the thfg macro to leverage the inclusion of this feature. Let me show what I mean. So I'm just checking if the feature f1 is existing. If so, the mod1 will be compiled. There's also a way to use a macro, this one, inside a function, and then you can just say if and execute the code. It's basically like if def in C and C++ as a preprocessor. But now we have a problem, as code can't be sure that mod1 will be existing. What I will do now is work around that situation. And now I just do the same thing down here. And now I add a knot around it so I can negate this. And now we can switch the feature on and off. Let us run the code right now and you see I'm a service and I'm a mod without f1. And now I kind of fake the situation that I would basically add the dependency. Oh, it's features. And if I now add that, so the feature is compiled in. And it's also in the binary. This will now not be existing in the compiled code. Only this path will exist. This is super interesting to structure your modules. So you can say if someone wants to use certain features of your library, the library user could be enabled to remove certain features or not. You see, this is leveraged in other projects which are widely used. So you can also do the same thing with imports actually. You can make conditional imports with. So I can just say, please import it. And so you are able to let, for example, the library user choose which modules are imported in your code if you are importing external crates, which is super nice. So you can completely lower down your code base for the library user. Now we will switch into some other projects. So first, let's have a look into Tokio. We will see how they organize their code. So this is a repository, and in there we go directly into the Tokio folder. And there we already see the basic scaffolded structure. And in there we have the source folder. And now we are just looking for the lib or the main RS. But in this case, it's the lib RS. And if we now ditch all this configuration part, we will relatively fast come to the imported modules. They are importing their macros, but as you can already see, they are using other macros to determine if this is imported or not, I guess. And here you can already see they have built their own complete macros. If you activate these features, I guess, they will include these modules. Otherwise, they won't be compiled into your code. And here is another interesting way to use it. There's also an all operator or function. This just means if you use fs, io, or net, or all Windows and process, this mod blocking will be included. And yeah, this goes on and on and on. Let's now go a little bit deeper. We have, for example, seen the macros. If we now go into that folder, we will find a mod rs in here. And there they are doing the same thing. They're organizing their module folder and submodules, if existing. In this case, they aren't, but as you can see, they have ready, pin, loom, config, and so on and so on. But let's see some common ones which are basically included. Let's take the mod loom, for example. Now we have a loom.rs, and in there is only a macro rule, obviously. So maybe the select will give us some functions. Let's see. You can see they are using these features a lot, and my object was to show you how these compiler directives are used to determine which code is included. Yeah, this is basically Tokio. Let's have a look into serde. This is basically a serialization and deserialization library. It's commonly used for JSON. Then it's called serde JSON. And let's have a look into the librs. This is a really cool thing they do here. I didn't know of that on my side, to be honest. They are restructuring or building a general library, which they will use internally all the time. The lib core, and there they put in like the standard, some features from the core module and from the standard, and they will then include the functions they want to use. So then they can just call lib : and then use these functions, so that they don't have to include them in every module where they will use them. Otherwise, their imports will blow up. And this is a really cool idea to get a little bit of order in your, let's say, common used modules from other libraries. Then we can have a look in here. There's also, again, a mod.rs file where they do some organizational stuff again for this certain folder of modules and subfolders. And you see they are importing a little bit more stuff. And here is what I actually meant. They implement for format error another custom function, and yeah, so on and so on. These are just some predefined formatters and serialization functions. That wraps up today's video. I hope you could learn something. Share some comments below. I will also link everything in the description and add a GitHub repository. See you soon. Bye.